Welcome. On this video, we will introduce the idea of a parabola. So let's get started. Now, the unit that we're going to be discussing overall is going to be conic sections. So let's just illustrate how does a parabola come from the conic. So here we have two cones, and notice that we have a plane that intersects these two cones, but more importantly, just concentrate on the bottom part. And notice that at least the way that this plane is intersecting this cone, notice that the intersection, it creates this U shape. And this U shape is what we're going to refer to as a parabola. Now, this U shape is not just an ordinary U shape, it has special properties to it. And let's discuss those properties and let's define the equation based on those properties. So if we stay away from a three-dimensional illustration of what a parabola is, and we just concentrate on a two-dimensional, here is what we have a parabola, which what you have seen in the past. And, you know, pre- perhaps in your previous classes, well, a parabola is just a U-shaped graph. But we're going to go a little more into detail, and we're going to be discussing that a parabola, it is composed of two very important points, or one point and one line. More importantly, the focus. So the focus of a parabola will always be inside the function or inside the graph. So if my parabola is open up, then my focus is going to be on the top. If my parabola would have been opening to the left, then my focus is going to be on the left, and so forward. We're going to use this point in a second. And most importantly, we're also going to define what we call a directrix, which is just a line that is opposite of the focus. So if the focus is on the upper part, then the directrix is in the bottom. If the focus is on the left, then our directrix is on the right, and so forward. And we're going to be defining a parabola based on these two properties, the focus and the directrix. And the way that we're going to be defining a parabola is as follows. So a parabola, it's pretty much a graph. At least we want to define it in terms of a graph. So it is a graph where all points in the parabola are equidistant to the focus and the directrix. But what do we mean by this? Well, what we mean is the following. So if we define this to be our parabola, and this point to be our focus, and this point to be our directrix, we know that it is a parabola if I choose any point in my graph. Let me just choose this point right here. Oops, that's definitely too big. So let's just choose one more time. Okay, so that's better. So if I choose this point in my graph, I know that this point, it is part of a parabola if I measure the distance from this point to the focus, and whatever this distance is, it is the same distance from that same point to the directrix. So any point in this parabola should have this property. Let me choose another point right here. So let's say I choose this point right here. Now, is this point part of a parabola? Well, one way to find out if it's part of a parabola is if I take a look at this point and I measure the distance from this point to the focus. Let's say that this distance is 3 centimeters. And if that is the same distance from that point to the directrix, then we know that it is a parabola. And this is true for any point in my parabola. If I would have chose this point right here, if I would have taken out a ruler, and if I would have measured the distance from this point to the focus, whatever this distance is from this point to the focus should be the same distance from this point to the directrix. And that is how we're going to be defining parabola. It's just a set of points that are equidistant to the focus and the directrix. Now that we have a basic idea of what a parabola is, let's just introduce some of the variables that we're going to be using along our definitions. And the first variable that we're going to be introducing is a variable, which we're going to use the letter P for it, and the vertex is going to be P units away from the focus and P units away from the directrix. Now, does that make sense? Well, let's see. I mean, if we choose the vertex of this parabola, notice that this vertex is definitely part of a parabola. And we say that all points in the parabola are equidistant to the focus and the directrix. So definitely the vertex should be equidistant to the focus and the directrix. And this is a very special distance. The distance from the vertex to the focus is what we call the focal point or the focal distance. And we're going to be using this focal distance in a bit. But I do want to make a small distinction on this. Now, the way that we have defined the parabola previously, that doesn't mean that all points have the same distance to the focus and directrix. So definitely, the distance from the vertex to the focus and the distance from the vertex to the directrix is not the same if we compare it to this point. But what we're trying to say on the previous definition is that at this point, if I were to measure, let's say I get a distance of 7 centimeters here, then if this is part of a parabola, then this definitely be 7 centimeters as well. If we got the vertex, let's say this is just 2 centimeters from here. If the distance from the vertex to the focus is 2 centimeters, then the distance from the vertex to the directrix, it should be 2 centimeters as well. So any point should be equidistant towards the focus and the directrix, but that doesn't mean that all points are the same distance away from the focus and the directrix. And this is a very important idea, the focal distance. This is a very important distance because it is the distance from the vertex towards the focus and the vertex to the directrix. And again, the distance from the focus to the vertex should be the same distance from the vertex to the directrix. And we're going to use that in a second. But now, if this is all we have discussed regarding parabolas, then where does the equation of the parabola come from? Well, we're going to be discussing two equations when it comes to parabolas. And the first equation that we're going to be introducing here is going to be the equation of a parabola regarding from the distance from the focus and directrix. So if we have the exact definition or the exact location of the focus and the exact definition of a directrix, is it possible for us to define the equation of this parabola? Yes, that's enough information for us to have that. But where does that equation comes from? Well, let's introduce some variables. So let's introduce some variables here. Let's say that the location of the focus point is going to be at the location A comma B. And let's just choose a random point. Let's choose this point, which is X comma Y. And lastly, let's say that the directrix is going to be defined as Y equals K. And why is it K? K is just a constant. It's just a value. It's just a numerical value. Notice that it's a straight line, so definitely this equation is just a constant. So all we have done is said, look, the focus is going to be defined at the location A comma B. This straight line is going to be defined as Y equals K. And this point on the parabola, we don't know its exact location, so I'm just going to define it as X comma Y. And now that we have this, we should be asking ourselves this question: what do we know about parabolas? Well, I know one thing about parabolas, and that is that any point in my parabola should be equidistant from the directrix, and it should have the same distance as it does towards the focus. So these two lines that I have highlighted in green and yellow, they should be the same, they should be equivalent. The distance from those 2 points should be equivalent. So if we're talking about distance, I know that they must be equivalent to each other. So we can use the distance formula. Well, now note that this is a vertical line. So definitely I can find out the distance to be y minus k squared And notice that that is the distance from the yellow line here. And now to define the green line here, notice that that's the distance between those 2 points. So we can definitely use the distance formula, which we can define as x minus y. I'm sorry, x minus a squared plus y minus b squared. And notice that this is just nothing more than the length of this yellow line. So this is, where does this come? This comes from the definition of parabola. The yellow distance should be equivalent to the green distance, and that's all that we have done here. So technically speaking, this can be the equation of this parabola. But notice that we have y's on different places. So let's just try to manipulate this equation a little bit further. Let me just erase this, because now we're going to be doing a lot of algebra now. So let's try to simplify this expression. Well, the first thing that I can notice is, well, what happens if I take the square root on both sides? So if I take the square roots, at least my equation is going to get simplified, because now the square root is going to cancel out with this. So now I have, well, I think it's better if I just drop the parentheses. So now we just have y minus k. And on the right-hand side, so now that I'm thinking about it, let's just not do that. And let's just go back to the original, because I can see a problem start developing. So let's just go back to the original equation that we had here. And let's just expand some of those expressions instead. So instead of writing y minus k squared, let me expand that. And if I expand that expression, I'm going to end up with y squared minus 2yk plus k squared. And at least on the right-hand side, I'm just going to be expanding this expression, because notice that this is the expression that has a y on it. So there's no need for us to expand this right now. So I'm going to keep the first term as it is, y minus a squared. And now if I expand this expression, I'm going to end up with y squared minus 2yb plus b squared. And notice that by doing this, the y squares are going to cancel out. So that's good. We're making our expression a little bit more into more simple terms. So let me just bring down what we have here. Plus k squared equals x minus a squared minus 2yb plus b squared. And by doing this, I'm just going to isolate those terms that have a y on it. So notice that I'm going to put all the terms with the y on the left-hand side. So here we have an expression. So let me just move it to the right-hand side. Minus 2yb. And now let me get rid of this k squared. Let me just move it to the right-hand side. So let me just subtract minus k squared on both sides. So by doing this, this term is going to cancel out. These terms are going to cancel out. So now I have minus 2. Well, let's just write the positive first. So I'm going to have 2yb minus 2yk equals, I still have this big expression. So x minus a squared, that cancels out. So now we're going to have b squared minus k squared. Notice that all I'm doing, I'm just writing down those expressions that have a y on it on the left-hand side. And why is that? Because now that I have this, I can see that they have a 2y in common. So let me factor that out. So if I factor out 2y, now I'm going to have b minus k. And I know that the first expression is still x minus a. But notice that bk minus k squared, that's a difference of squares. So I can definitely write this as just b plus k times b minus k. Well, why am I doing this? Because notice that on the left-hand side, I have a b minus k, and it's been multiplied. So now, what happens to my equation if I divide it by bk, or b minus k? So let me just divide b minus k on both sides. Boom, that's done. So now I have 2y equals, I still have this expression, unfortunately. Well, let me just write everything in black. I was going to confuse here. So I have 2y, and that's equivalent to x minus a squared over b minus k. But now notice that now this term is going to cancel out with this term, which is good, because all we're doing right now is just doing algebraic manipulation to simplify our results. So this is what I have so far. And if I want to just have an equation in terms of y, so all I got to do here is just multiply 1/2 to every single one of them here. Times 1/2, times 1/2, times 1/2. So now what we're going to end up with is the following. Now this is going to cancel out. And now finally, after doing all this manipulation, I have an equation which I can use to properly define a parabola just in terms of its focus and directrix. So here we have an equation which we can definitely use to define a parabola just in terms of its focus and directrix, where remember that the value AB is the vertex, and remember that K is the constant that we use to define our directrix. I'm sorry, AB is our focus, and XY is just a point in our parabola. And now this is just one way that we can define our parabola. So if we know the location of the focus and the value of the directrix, then we can definitely use that to define the parabola. But now we're not going to derive the following, but there's actually a different way which we can use to define a parabola. So we can define a parabola, but just in terms of its focal distance. And the vertex. So let's assume that we don't know exactly where the focal point is defined. Let's say we don't know exactly where the focus point is and where the directrix is. But if we know the location of the vertex and we know the distance from the vertex to the focus, which we define as the focal distance, then we can define our parabola as follows. And again, we're not going to have time to derive this. But if we only know the focal distance and the vertex, we can define our parabola as 1 minus k squared equals 4p x minus h, where in this case p, it is the focal distance, and h and k, it is the value of the vertex. And I'm going to put a little bit of an asterisk on this equation here, because there's different ways that we can define our parabola, and we're going to discuss that in a second. But now, notice that we have two equations which we can use to define a parabola. On the left-hand side, we can use this equation if we know the location of the focus and the location of the directrix. Let's say we don't know the location of those two values there, but if we know the focal distance and the vertex, then we can definitely use the equation that we have defined here. And notice that even though the left-hand side looks a little more intimidating, all we did, we just defined that equation based on its definition of a parabola. On the right-hand side, we're not going to have to derive it, but we're just going to state it. So very important, two ways that we can define a parabola. Facing upwards. So not all parabolas are always going to be facing upwards. So let's take a look at different examples. So here, notice that there are 4 different directions that we're going to be discussing in this class when it comes to parabolas. And here we have a parabola that is facing upwards, downwards, to the right, and to the left. And the direction of the parabola, it's definitely going to impact the way that we're going to be defining our equations. And we're actually going to separate these 4 graphs into 2 groups. Whenever my parabola is facing in a vertical manner, either up and down, or whenever my parabola is facing a horizontal manner, left or right. And let's just see what's the difference between those two. So let me just make this a little bit more straight. So what's the difference between those two? Well, if my parabola is facing upwards, notice that here we have a parabola, here we have our focus point, here we have our directrix, and here we have our focal distance. Notice the equation that we use for that situation. And this is exactly the same equation that we have just stated here, but differently. So what seems to be the difference between those two? Well, let's take a look at the way that we have defined it here. We have y minus k squared equals 4p x minus h. Well, if my equation seems to be opening up or down, notice that the x variable, it's the one that is being raised to the second. And the y variable doesn't have a second exponent on it. But still, h and k, it's still my vertex, and p is still my focal distance. So that's the first distinction that we should make. If my equation it's opening up or down, my variable x is the one that is going to be affected by the second exponent. Now, what seems to be the difference between up or down? Well, notice that that is being determined by the focus. So if this is my parabola and my focus it's on the top, then definitely my parabola should be opening upwards. Still, if I have a parabola and my focus is defined as a bottom, then notice that now my parabola is facing down. And if my parabola is facing upwards, then I'm going to say that P is going to have a positive value. In other words, the focal distance, it's positive. And if my parabola it's facing downwards, notice that we're going to be assigning a negative focal distance. So let's fix this. So if my parabola it's facing upwards, then my equation is going to have the following form. Positive 4p y minus k. And if my parabola it's facing downwards, then now my equation is going to look a little bit different because now I know that if it's facing downwards, this value of p is negative, so I can just rewrite it as negative 4p y minus k. And these are the equations, so these are the standard forms that we're going to be using along our class. So if my parabola is facing upwards, then this is the equation that we'll be using. X value or x variable is to the second, and p is positive. And if my parabola is facing downwards, the x value is positive, and now my p is negative. And now what happens if it's opening left and right? Well, there's a small distinction. So now if my parabolas are opening either left or right, the y value, it is the one that has been raised to the second exponent. And now the x value, it's the one that doesn't have a second exponent on it. So notice that it's essentially the same equation. The only thing that differs is the location of x and y. Very important distinction. If it's opening in a horizontal manner, the y is the one that is going to have a second exponent on it. And notice that it's switching from x minus h to y minus k because k is the y value on my vertex. So therefore, it should be attached to the y and so forward. The h is the x value in my vertex. So definitely h should be attached to x. And what seems to be the distinction between those two? Well, if my parabola it's facing to the right, so if my parabola is facing to the right-hand side, so we're going to be assigning a positive focal distance. And if my parabola it's facing to the left, then I'm going to be assigning a negative focal distance. So if that's true, then how is our equation going to look like? Well, for any parabola that is opening to the right-hand side, the equation that we'll be using is y minus k squared equals 4p x minus h. And for any parabola that is facing to the left-hand side, we know that p must have a negative value, so therefore it affects my equation as follows, equals negative 4px minus h. And these are the four different equations that we'll be using to define parabolas, because more than anything, we're going to be using a focal distance instead of the actual focus and the directrix. But these are the four equations that we should be familiar with. And know that if it opens horizontally, if it opens vertically, then we will always going to have x minus h squared. And if it's opening horizontally, we're going to have y minus k squared. So let's just do a quick example, since this is a lot of just theoretical and more than anything, just a small explanation as to where these equations come from. So let's actually do a quick example. So let's find the standard form of an equation of a parabola whose vertex it's at the origin, and we have a focus at the location 0, 4. So let's start by creating a sketch. So let's just do a quick sketch here. So I know that the vertex, let me actually do that in green. I know that the vertex, it's at the origin. So let's just say that the vertex is at the origin. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And now I also know that the focus, which let me do that in blue. I also know that the focus is at the location 0, 4. So that's going to be 1, 2, 3, 4. So now let's think about the direction of the parabola. Let's think about the direction of the parabola. So if this is my vertex, and again, the vertex, it is part of the parabola, and this is my focus, then what's the direction that my parabola should be taking? Well, the parabola should always be pointing towards the focus. So if the focus is upwards, then I know that my parabola should look something like this. Now again, if my focus would have been on the right-hand side, then my parabola would have looked something like this. If my focus would have been on the bottom, then my parabola should look something like this. And if my focus is on the left-hand side, then my parabola would have been opening leftward. And that's all we know. So now that we know that it's opening upwards, then I know that the standard form that we're going to be using here, it's going to be this equation. X minus h squared equals 4p y minus k, because that's the standard form equation of a parabola that is facing upwards. So let's just write that down. So the standard form that we're going to be using is x minus h squared equals 4p y minus k. And what information do we know from this? Well, I know that the focus is at the location of 0, 4, and the vertex is 0, 0. But recall that there are two things that we need in order for us to use this equation. We need the focal distance, and we need to know the vertex. But we already know what the vertex is. The vertex is 0, 0. But now, do we have enough information to find the focal distance? Well, the focal distance is the distance from the focus to the vertex. And that's exactly 1, 2, 3, 4 units. And that's actually all we need. Because now that once we know the focal distance and once we know the vertex, then we just plug it into our equation and we're pretty much done. Because h and k are the value of my vertex, and in this case, p has a value of positive 4 units. So all we gotta do, we're just gonna plug them in here. So here we have our h, here we have our k, which we know it's 0, 0, and here we also know our value of p, which is 4. So let's just plug that in there. So now our equation is going to look like x minus 0 squared equals 4 times p, where p is 4, y minus k, where k is 0. Now let's just simplify this. X minus 0 squared, well, that's just x squared. 4 times 4, that's 16. and y minus 0 is just y. And we just simplify this. We have x squared equals 16y. And just for formality, let's just solve for y. So let's just divide it by 16 on the left and the right. And now we're going to have an equation which we can define as just as y equals x squared over 16. Notice that this seems to be a very simple problem, but notice that we have to explain what everything means in order for us to just be able to understand the standard form of the parabola. So notice that this has only been a small introduction of a parabola, which concentrated on equations based on its directrix and the point of the parabola, and another one regarding the distance and the vertex. We have discussed the 4 different directions that we can take on a parabola and how that affects the standard form in terms of its vertex and focal distance, and we have done a small example on this. And with this, it concludes our lesson on the introduction of parabolas.